all together. And hello, Matthias. Nice
Hi,
to
how are
meet you
you?
again.
Yes, absolutely.
I'm good. It's May. The update was not here yet, but today you have a very special topic that's very timeless.
Hmm.
Yeah. So
Yes, indeed. Um, also a bit theoretical, but hopefully we can make it interesting and appealing. Talk about Git workflows. You know what a Git workflow is?
yes, I know from one of our earlier talks. There you introduced them, and also from projects. But for me, it's like a side issue. And I
Hmm.
also know, okay, we need branches. We need a branch for features. We need a branch for bugs. We need a branch sometimes for testing, and then we need to merge them all together. And this is the knowledge I basically have in this. And of course, the tools are supporting it in different ways, like
Mm-hmm.
DevOps, GitHub, and the others, like GitLab or Bitbucket, but I never worked with these two.
Mm-hmm.
And of course, or I think there are also more around. Yeah, but you as full-blooded DevOps guy and CI/CD master, you can tell us definitely more about the
Yeah.
workflows. And then I feel free to ask. And we have like a good tutorial for this topic, I think.
Yeah, hopefully we get some audience questions as well.
Hmm.
Git workflows is something I've been thinking about and studying and researching and playing around with for quite a long time now. And in a nutshell, it's basically a process which determines how you or your team use Git. And that seems a little strange maybe at first, because one would think that I use Git, so there's one way of doing that, but in reality, that's not the case at all. There are many different ways of actually using Git source control, and they unique and quite different actually. Let me share my screen, and hopefully I can help people make sense of things a little better. So if I
Yes.
go here, share screen, and then I do this one. Okay. Can you see?
Yes. Here you go.
Very good. So, what is a Git workflow? In my definition, it's a branching model. So the rock is you select. There's basically a wide choice. You need to select the one that works for your project, for your team. It will give you a branching model. It basically tells you which branches you want to maintain, what they're named, and what their purpose is. Um, it effectively tells you how something production. Do you have different stages? Do changes have to go through certain other branches first? Uh, and basically related, do you test and review? Um, do you rely on automation? Do you rely on a review process? Is it a mix of all of that? Also, versioning is actually I'm uh, personally really passionate about, particularly semantic versioning. Um, and it's definitely part of your Git workflow as well. What do you version? How do you version? At which point is a new version applied, or at which point do you increment your versions? Um, and then the another really important topic is how do you apply hotkeys? You push changes into production. A user, hopefully not your CFO, tells you that something doesn't quite add up, or there's a mistake there. So you actually get this fixed, or potentially even roll back to a previous version that is good. And oops, was a little too fast. Oh, here we go. Yes. And ultimately, I talked about that implicitly already. Your Git workflow determines whether or not you environment, how they actually map to your process and to your branches. So what I want to do today is to present and explain two very common Git workflows. And I picked two which represent completely opposite ends of the spectrum. You're going to in a second. One is the so-called Git flow. And before I go into the detail, just sort of have a look at this picture, right? We see 1, 2, 3, 4 different branches. We see lots of arrows and lots of basically merges and connections between the branches. So that's one we want to look at. And then the other one we want to look at is this one, Git, which sounds almost exactly the same, but it's the polar opposite of Git flow. And GitHub flow is very agile, it's very simple, as you can tell. And it is a so-called trunk-based development flow. But let's start off with Git flow to begin with. So Git flow is a relatively old system. I think it was first talked about in 2010. So that's 14 years ago now. I mean, in IT terms, that's like the Stone Age, right? And as you can see, it's using lots of branches. Let me just go here. We've got what nowadays is usually called main. Back then, was called master. So that's basically the trunk or the main line, as the flow is also called. And that one basically represents official releases, right? We can also see the blue dots along here. They are tagged with version numbers, which represent our releases. We have can I get everything on right? So yeah, so this should work. We have a dedicated branch for hotfixes. So as I said before, is found to be problematic in production, we can immediately create a hotfix branch, work on the fix as quickly as possible, and push it straight back into main once it's ready. That is the exception, obviously, right? Generally, you will not just work in hotfix. The normal case is to have a release branch where you basically plan a particular release for the near future. You decide maybe using a sprint system or so, what goes into the release and when you're planning to have the release ready. You create a dedicated branch which will also contain everything that goes into that release right before it goes back into main. The develop branch, which is another very which is another constant branch of this flow, is where most of the work happens. Basically, individual developers create feature branches for specific features. Whenever they basically integrate their changes into develop. When specific features are integrated and tested, they go in this branch. That also means, if I just zoom out, that here we go, certain things. let me see. This is an example. Certain things don't make it into a release, either because they're not ready yet or because they missed the cutoff point. And the advantages of the flow here. Because you can basically do parallel work on as many features as you want. That's fully supported, and they basically go into your release whenever you're ready. So just to recap, we start off with where we're at in production right now. We then merge that into our current branch in order to begin work on a new sprint. Individual developers then create feature branches in order to track different features. Those ones get merged back into develop whenever they're ready. That's pretty much where integration happens. And ultimately, we stage things in our release branch. That release branch may require some fixes before the release is ready to basically go into production. And the hotfix path is simplified in the sense that we're going straight from master or main to our hotfix branch and then immediately back, because obviously we need to be very quick here. So as you can tell, there's a lot to explain. There's a lot to talk about. But this system has great advantages for bigger, for complex systems, and also for things. I personally prefer this model, semantic inferences, where you have a really, really high quality bar and where you don't necessarily make very frequent and small changes. We basically plan ahead what you're going to change, develop sort of a larger chunk in one go, and then make an explicit release. Make sense? Okay.
Yes, I think it's quite a good thing to separate them and to let the people work. Dedicated on some stuff, but of course the merging process is a little bit challenging. So you really have to know what you're doing then.
Indeed. So basically every single arrow here is a merge, right? So between different branches. And as you can see, this requires lots of merges, which also means there is a lot of potential, to get merge conflicts and to having to work around, the difficulty you get from doing parallel work, right? So, which is why, let me just move on. Oopsie, sorry. Which is why over time GitHub came up with the GitHub flow, and I'm presenting those two today, not because they're only two. If you sort of go to Google or Bing and look for Git workflow, you're gonna see a barrage of different ones. GitLab, for instance, has the GitLab flow. It doesn't mean that every single CI system has its own flow, but it basically models out there, and that's a good thing because different types of projects and different teams just have different requirements. So GitHub flow is highly simplified. It basically means you have your main branch called master here, and you in very small units that get worked on and get reintegrated into master or main as quickly as possible. And basically, you constantly create new deployable units. That is extremely agile, very simple, but so has lots of advantages in terms of speed. But as you can see, there are disadvantages as well in with respect to, well, how do you test? So GitHub Flow is an extreme example for trunk-based development, and that one works best when you have a proper CI/CD system in place. CI/CD meaning you have full automation regarding bringing changes into your main system and ultimately bringing those changes out into production. With a high degree of automation, particularly around testing, this is not a flow that actually works very well. But hypothetically, if you are in a position where most of your testing is automated, this is because you can have complete confidence that any change that gets pushed back into master is good, right? Your testing system should be your guard here. And let me just move on here. So I basically put a comparison in place. Just you can see side by side many branches, a very complex system for Git flow. On the other hand, we've got frequent releases in GitHub. We have the ability to work on multiple features in parallel. We've got the ability to roll back. On the other hand, with GitHub Flow, we are extremely agile, and we actually have a flow that works perfectly with a fully automated CI/CD system. Testing is a big from my point of view. Git Flow leans more towards manual testing and really thorough testing, whereas GitHub Flow, because of the agility, basically relies on all testing. I've already talked about branches, so much more complex system for Git Flow. And so cons, definitely much more overhead for Git Flow. So I said that before. If we want to apply this to the Power BI world, and just sort of wanted to be very, very high level and simplified here, I would say semantic models are something much more suitable for Git Flow, whereas reports arguably are much more suitable for GitHub Flow, right? And when I say report, I explicitly mean sort of visual aspects of report pages, not DAX formulas and any semantic model features. So I would argue that looking at a report just from a visual point of view, you do not require a super high quality bar, right? If a particular visual or you don't quite have the right color, that's okay. And it's something you can fix quickly, but it won't actually send a completely wrong message in terms of the metrics you want to create. Those come from semantic model, right? So I would personally argue that semantic models, just because they basically contain the intelligence of what you're giving to your stakeholders, they require a much more thorough model and they you should allow yourself to basically think about sort of a slightly slower moving process in order to benefit quality. Yeah, so that's that. There are a few links I'm happy to share offline as well if people want to read up about that. I prepared a little demo, but more than happy sort of to break here and maybe respond to some questions or sort of go back into some specific details in more detail if you want to.
Yeah, I see that you are watching, dear people. So, but no questions so far. So yeah, feel free to ask. I have some, but I maybe want to wait because it's more about when you strictly separate semantic models and reports. So when I think about Power BI or Fabric, there's some stuff that's in between or mixed up. So what we want you to do if the users use composite models, for example, or when they create some measures in a live report, or when they just change something in self-service in the workspace. But I think maybe I will wait the demo first, and maybe some questions will clear up when I see it.
Let me just go back here for briefly. I mean, ultimately, from my point of view, the choice is all about where your quality bar is, right? Agility, what you get on the right side with the GitHub flow has a huge benefit with respect to being able to deliver value to the business, right? And definitely something which we always want to strive for. However, you can't, in my opinion, you can't go for agility at any cost, right? And so it comes to ensuring that there are absolutely no regressions regarding key business metrics. It's really important that you either rely on heavy automated testing. Arguably, we don't really have good tooling for yet in the Fabric Power BI world. Or you rely on a really good process that ensures that reviews and QA takes place before something goes into production, right? So that's what I would start from. What is the quality bar, right? Who is the audience, right? Is it something ultimately goes to the executive board of a big multinational, or is it something that a small team occasionally looks at with respect to a sort of external data set, right? The higher the stakes in terms of quality, the more process you need from my point of view. And the more you want to rely on a good DevOps process with different environments and sort of a well-defined way to test anything that will ultimately change production. Hope that makes sense.
Yeah, and of course, I think there will be some mix of both in some scenarios, just for different workflow for different artifacts. Yeah, makes sense.
So, if you can see, yes, you can make this a little bigger, if that helps. Here we go. I've got, so I did not prepare an example for Git flow. Remember, Git flow is the one that has like 5 or 6 different branches, just because it would have been too confusing, I think, trying to do this. But I did prepare an example for GitHub flow, the simple one. So I've got a PPIP with a data set and a report. By the way, in an upcoming version of desktop, this .dataset will be renamed to semantic. In fact, I think it has that already happened back in April, actually. So this is still sort of an old example. And remember, Git flow basically says, I've got production, I've got my features, right? So I've mapped that into two different workflows here by basically saying my production pipeline will run, got a push into my main branch, right? So this is my GitHub YAML file, and basically on is the keyword that determines my pipeline triggers. And whenever anything is pushed to main, this pipeline will run, and it's ultimately gonna deploy this data set with a refresh. And then, very simple, the development environment here would be whenever I've got a pull request, either created or modified into main, I'm doing a development. I'm running a development pipeline, which in an ideal world runs tests, but otherwise does a deployment into a dedicated environment, right? And which also means I'm on main right now, as you can see. So let me create a new branch. I can pretty much call this anything. So let's call this version bump. And this particular data set happens to have an about table, and we can see it has an inline M table. The version number is hard-coded, right? So I'm just going to do a very trivial change here. I'm basically going to update the version number from 1.0 to 1.1. And there we go. So bumped version, going to commit that. And now I can publish this as a new branch. If I now go to, here we go. This is my repo. It's, I think, yeah, that's public, by the way. So anyone watching can find that on the PBI tools GitHub. So right now, we don't have any pipelines running because remember the trigger was on pull request, right? So if I create a pull request now and basically say version 1.1 to go into main, the creation of this pull request will basically trigger my development pipeline. There we go. If you've watched my screen, you've seen that this actually kicked off fully automatically. So I can click across. This is now starting a pipeline, which ultimately uses PPI tools for dataset deployments. It's just running BPA rules here. And ultimately, it will push this data set into my workspace. Git, here we go. Right. So it's this one. Still running here. Actually, it's done now. We can see that's green. So if I go to my data, but by the way, that was an empty workspace. So this was complete. That was completely created from scratch. Again, you know, that's what you want to have from DevOps, being able to codify your entire environment and then pretty much point it to a new target or to a new environment and have it fully set up for you. So if I look at my about table here, that has 1.1 now, right? So there we go. So that's one example. That is half of the GitHub flow with respect to that particular semantic model. I now have a fully deployed version of that model in my dedicated dev environment. We can see, if I just go back to my Power BI, that first of all, the workspace has a dev suffix, and the model itself also has a development suffix. So I can clearly distinguish this from my production system, right? It's got a different name in a different workspace. I can now perform all kinds of testing until I'm happy that this should go into production, and then all it takes is for me to go in here and merge that pull request. That brings it into main, and that then automatically triggers my production pipeline, which I should see here. There we go. We can see there's a running this one into production because the pull request basically pushed into my main branch. That is the trigger for my production pipeline, and that one now takes the updated model and feeds that into my production workspace. So if I go here, right, so this is production. Let me do the same thing. Oh, well, sorry, it was too fast. I was hoping we would still see the old version here, but there we go. This is 2.1. And as you can see, the dataset does not have a suffix anymore. This is my production sales dataset, and it's in the production workspace. So there we go. So that shows how quick a particular flow is. However, it may not be suitable for every team and every type of project. And personally, I would probably not use that flow for semantic models, but you can, right? So at the end of the day, it's about understanding, well, what are the choices? What are the pros and cons? And what works for me?
Yeah, and I think the difference, okay, you can make very granular rollbacks too. If I notice any problems here, then I can just jump one step back, and the steps are really small, so we can check what's wrong. But of course, in a very centralized, high quality model, you don't want to do it all the time. So for me, it's like you said, it's a matter of the domain, like the enterprise level static reports should be treated different than some lower level reports, and also self-service semantic models, and all this stuff that the end users use and try to play around with. Cool. And this is all integrated with GitHub DevOps and Power BI workspaces, and now even the development pipelines make sense with all this Git integration.
And by the way, which DevOps server you're using, right? So I happen to be using GitHub here, but that would work in exactly the same way in Azure DevOps or Bitbucket or GitLab or any other system. Obviously, the YAML definition somehow different for each of those, but they all have the exact same capabilities.
Yeah.
It's then just sort of a technical detail, sort of how to implement the same pattern.
And here you used Power BI tools like as means to deploy and to check stuff. And also
Yes.
for some kind of automation and test automation because of the best practice
Yeah.
analyzer.
So PBI tools actually does the vast majority of the work here. The YAML pipeline and basically has two purposes. First of all, the key purpose is to define what is my trigger, right? Which is why I pointed out the on keyword earlier. And the second one is to basically be a way to invoke PBI tools and feed in certain parameters, right? So we can see here the production keyword is a parameter, so that basically tells which environment we're targeting. And then here we've got a variable which is hard-coded a bit further up in the same file, which represents a particular manifest. And that's it, right? That's the CI system does. Everything else is orchestrated and organized by PBI tools. So here, this is my definition where we're basically saying what type of deployment is this, where are the sources, how am I authenticating, how am I connecting to my external data sources. And then I've got additional features like dataset refresh, which is really crucial in a professional context. If you only deploy metadata, which is actually what the built-in Fabric tools do with Git integration, you're not getting very far. You need to orchestrate that refresh. And the other thing we're getting from using PBI tools here is the ability to use dynamic parameters, so that ultimately I can actually inject values and information from my CI system straight into my dataset. That's not actually done here because that's a very simplified system. But if we go to some other public examples I've got here, for instance, this one. That's Contoso SQL Dataset DevOps, also under PBI tools. And if we go to the manifest here, we can see that we actually have a whole number of parameters. And specifically, this one is using GitHub environment variables, which basically give us the ability to see the GitHub pipeline run ID and the GitHub commit SHA and the GitHub name. Those are all values which change or which potentially change with every single deployment. The ability to grab those here and to inject them into my model definition is highly important with respect to observability and with respect to being able to make a link between what's in my production environment or what's in my staging environment and how does this map to my source control system, right? So that's another feature we're getting from PBI tools here.
So do you use only supported functions there, or is anything left of the unsupported?
No,
Roots
that's all fully supported. I mean, to give an example, right? So basically, let's take so GitHub name. So that happens to be a standard GitHub environment variable, which in a pipeline run will always contain the branch name you're currently running against. And if we look at the set, this hasn't been updated to Timdal yet, as you can tell, but it still works. What am I looking for? So I'm actually looking for this. I'm looking for my M code. So here we go. So this is the M code. Right. So this would look slightly different in Timdal, but this particular demo precedes Timdal, as you can tell. It's the old proprietary source control format from PBI tools. But what we can see here is where the same pattern we saw in the other project is used. We basically have a metadata that's created using inline M table syntax. And here I've got a reference to a M parameter, which happens to be called gh-branch in bracket. So this is an M reference. That one is assigned to the table row that has the branch. And if we look here, we can see that's the M definition for this particular shared expression, right? And PBI tools basically uses certain conventions where if you define a deployment that happens to have the same name as a shared expression, it will automatically replace the value of it at deployment time, right? And so ultimately, if we then go here to look at the DAX for our branch measure, so we're talking about a DAX measure now, right? We can see that this is using the lookup value function, where it's basically using the coded term branch in order to find what happens to be the text in that particular DAX table row, right? And that text is what PBI tools will inject. So this ultimately allows us basically a measure into a report that shows us what branch ultimately the data set was built from. And it's really, really important if you want to rely on automation and if you want to multiple environments, you need full visibility with respect to what is my report actually linked to. You don't want to accidentally look at a development semantic model, that has fake data or that isn't updated way as my production model. So this is really important, even for end users, right? It's a pattern which I've used for many years, and where all my end users were always trained to make sure that they only look at production.
Cool. Okay, and one last question. Can you tell us something about merging conflicts when, for example, two persons are developing from different sessions and trying to push?
So a merge conflict is, well, the definition of a merge conflict basically is two changes were made sort of against the same version of the same file, right? So for instance, if we just go back here, so this is a Timdal. This is a Timdal project. I've got a table here, which happens to contain a measure called number of customers, right? So let's say one developer changes the format string to something else, and another developer changes the same format string also changes from a string to a third value. And both of them try to push this into the main, right? That would create a merge conflict, as in the merge would not succeed because someone would have to intervene to decide which format string should win, right? That is not something the system can decide. And at that point, you need human intervention. However, again, this is part of Git workflow, because using a process, you can use a process that basically avoids at least the possibility of merge conflicts completely, right? When you basically say, in my sprint that's starting now, only one particular person is a changes to the customer table, and no one else should be touching a customer table, right? Then we have we have complete guarantee that no merge conflict could ever occur, and we ensure that using our process. And so this is where basically technology and process need to come together. And again, coming back to the two corresponding or the two alternative models, using something like Git flow, where there more structure and a lot more process involved, can definitely help here. Whereas something that is much more agile, like GitHub Flow, it's a lot more difficult. So there is no way to prevent merge conflicts, but there are very, very good mitigations. And ultimately, that's part of selecting, the correct flow to begin with, and then sticking to it.
Okay, fantastic. I think I learned a lot, and it was a good overview about the options and workflows, some theory, but also some, real life examples, how make use of it. And as you told, it's all open and free in Power BI tools repo.
Yes, absolutely. Yeah, if you go to PBI tools in GitHub, you'll see GitHub Flow semantic model shows up as public. Right now it's the top because I only just created that earlier today. So everyone can go in here and basically clone it and run it in their own system. The only prerequisite there is a secret, because obviously we need to authenticate with the Power BI APIs, right? And it's important that a tree scoped secret is set up with this particular name, and it needs to contain the secret for a forgot now for a security token. It's not the right term. Hopefully you know what I mean. Got a bit of a brain freeze right now. So that's the only prerequisite. And let me just show you where this is showing up here. There we go. Service principle. That's the term I was missing. Sorry. So this service principle needs to exist. Obviously, this GUID will not work for anyone, but my own tenant. To put the client ID in here, and then the corresponding client secret into your GitHub project, and then the whole thing will just work, because the only data connection it requires is actually a HTTP connection, this one, and that is of type anonymous, as it require It doesn't require any credentials whatsoever. So this is a plug and play. As long as you have the service principle in place, you're good to go with that one.
Yeah, fantastic. And yeah, as I see no more questions. So a few seconds are left if anyone has anything, but it was quite a thorough, complete demo. I think we can, yeah, leave it with that. And of course, next week we will see you again at Data Grill, I think. Right,
Looking forward
Matthias?
to it.
Yeah. So
Okay, bye.
it will be fantastic. And thanks again for everyone for watching.
Thank you.